everyone. Thank you for joining me today. My name is Elena Adraki. I'm a student of SIT 103 Diploma of IT. In this presentation, I will be discussing fundamentals of blockchain technology and its impact on securing data in the digital age. Well, let's go to our next slide. In this slide, I will be introduce you the blockchain. Well, did you know that blockchain distributed architecture was a big revolution in data security and data management? That is because we call it revolutionary technology. When blockchain came into existence, it completely changed how data is organized and managed. At first, it seemed complicated and difficult to understand, but it quickly made a big change. Blockchain introduced new ways of data managing. But what is exactly blockchain? Blockchain is a secure, shared, decentralized, and immutable ledger that helps the process of recording transactions and tracking assets in the business work. But what are the features, special features of a blockchain that make it different from the other data managing systems? The first one is decentralization. Decentralization in blockchain means control is distributed across many independent computers rather than being held by a single authority. This approach enhances security as no single entity can control or alter the data and promotes transparency since all participants can verify transaction. Next feature is distributed ledger technology, or known as DLT. DLT in blockchain is similar to shared digital notebook, in which everyone has a copy. When a transaction occurs, it is recorded in this notebook where everyone in the group can view it because everyone has the same copy. It is nearly impossible to cheat or alter the records, making uh, blockchain secure and reliable. Immutable records is the next one that I want to talk about. Once a transaction is added to the shared ledger, no one can alter or tamper with it. If there is a mistake in the transaction, the only way to correct it is by creating a new transaction to reverse the error. But it's important to know that both original and the corrected transaction remains visible to everyone. And the secure. Well, as I mentioned in previous ones, all of those other features make a blockchain secure. Let's go to the next slide. Blockchain structure. Well, blockchain uses some concepts in its system, and I'm going to explain a couple of them, which, as you can see, it's block, node, hashing, and Merkle tree. What is block? With a block serving as a fundamental building block, a blockchain records transactions that occur within a given time frame. These pieces come together to form a chain of linked pieces that are connected both linearly and temporally. What are the nodes? Nodes in a blockchain network are computers that validate and record transactions. They maintain copies of the entire blockchain, ensuring everyone has the same data. Nodes work together to update and synchronize the blockchain across the network. Their collaborative effort ensures the security and consistency of the blockchain system. As you can see in this picture, the users of the systems can be human, IoT devices, and sensors, but all of them are using the nodes and working with the nodes, which are the systems in a blockchain network. Next one is hashing. What is hashing? Hashing is a process of using a mathematical algorithm to transform input data into fixed length string of characters, usually a hash code. The SHA-256 hashing algorithm, as you can see here, which generates a 256-bit hash value, is frequently used in blockchain. Assuring the integrity of the input data, this hash code provides a unique represent, representation of it. What is Merkle tree? Merkle tree, um, actually in Merkle tree, the transactions are hashed separately, combined and duplicated until a single hash, as you can see here. At the end, we have only one single hash. This serves as a summary of transaction within a block, detecting unauthorized changes and tampering. It also allows quick verification of transaction without downloading the entire block. And it's good to mention that a transaction is a record of an action or exchange of value between parties that is lodged in a blockchain to ensure its integrity and transparency. The transactions can be made between all nodes whenever they're generated. I believe that I have to talk about transactions because it's an important part, but I thought that they're not important as these four items, so I didn't mention in my slide. But before going to next slide, I want to explain more about the block um, structure. As you can see, the block structure has two parts, block header and block body. Well, the point I want to talk about specifically is about this part, previous block hash. Well, as I said, the block connects and join together and make a chain of block. And the point is that these blocks are connected together through this previous block hash. It means each block is connected to the previous one through this previous block hash. And that was the thing I wanted to specifically mention that. Well, let's go to the next slide. In this slide, I will be discuss about blockchain breakdown structure. The first layer, which is the lowest layer, is data layer. It stores all transactions in a block. Each block references the previous one, making tampering difficult. And the next one is network layer. This layer is blocked in blockchain breaks like sharing news in a group. Imagine you have news to share with your friends, and you tell one friend who tells the next person, and so on until everyone in a group knows the news. Consensus layer. The consensus protocol in blockchain is like quality check to ensure everything is done correctly. Just imagine a teacher collecting assignments in a class and checking each one to make sure they're done correctly before giving grades. The next one is an incentive layer. Provides This layer provides rewards to nodes for validating transaction to encourage participation. There is a point that I want to talk about it here. In some sources, blockchain described with five layers, combining the last two layer into a single and call it application layer. In others, it is described with six layers, distinguishing between the contract layer and the application separately. Well, contract layer, which is in this picture, is a fifth layer, um, that contains smart contracts and scripts that execute automatically based on the predefined conditions. And the last one, which is application layer, and is the top layer, is the is that the blockchain is used in a real world application like IoT and healthcare. And that was the blockchain layers. Let's go to the next slide. Well, it is important to say that before the advent of blockchain, all data was stored uh, centrally, meaning all data was kept in a single location. This system implied that if something happened to the location, all data would be lost, which is very risky. Blockchain reduced this risk by providing decentralized data organization, as data is stored across multiple locations, ensuring that the loss of or damage of single point does not result in total loss of the data. Let's go to the next slide. The usage of blockchain in digital currency. Well, it's important to know what is digital currency exactly. It is the money used for online transaction, and it only exists online. But let's talk about the usage. Please imagine a situation when user A, for instance, one of this node we can call user A, wants to send money to user B. A needs B's wallet address, similar to needing an email address or send a message. After A initiates that the transaction must be verified by all nodes in the blockchain network. Each node records the transaction, which is then stored across thousands of computers, creating numerous records of same transaction. This process ensures that the transaction is accurate and cannot be altered or tampered with. And before the conclusion, I want to talk about the usage of blockchain in big data. There are actually, before saying the items, it is important to know what is big data. Big data is a combination of structured, semi structured, and unstructured data. Well, to just say what they are, this kind of data is what they are. A structured data is something like text, for example the phone number, age, something like this, called structured data. The semi-structured data, there are text files, for example PDFs or the JSON file. If you're doing programming, you should know that. These are the semi-structured data, but the unstructured data, they're like emails, videos, images. And in big data, the organizations collect, analyze, and mine for information and insights. Uh, Blockchain technology offers significant benefits when integrated with a big data system. Here is how it enhances various aspects of data management. Well, the first one is secure data and keep it private. Blockchain ensures data privacy, but encrypting information and distributing it across a decentralized network. Make transactions easier by automating and securing data exchange through smart contracts. Blockchain reduce errors and streamlines complex transactions. And the last one is trust in external data. Well, blockchain increased transparency by providing a clear, verifiable record of transaction. This transparency helps verify and authenticity, of external data sources and builds trust among stakeholders. And in the conclusion, let's talk about blockchain impact. Blockchain enhances data security, transparency, and efficiency through its decentralized structure. But what is blockchain challenges? It faces issues like inefficiency, high costs, slower speed, and scalability. And the last one I want to talk about in this presentation is the future potential. But blockchain's future is promising, with potential for transformative impact across industries as it evolves and overcomes current limitations. Well, at the end, thank you for paying attention to my presentation. I hope you enjoy. Thank you.